अस्सलाम वालेकुम, आपको मेरी आवाज आ रही है?
यस सर।
रिकॉर्डिंग स्टार्ट करिए। बिस्मिल्लाहिर्रहमानिर्रहीम। Continuing from the last lecture, we are still in chapter number 1, right? And lecture number 2, second lecture, right? And chapter number 1. We were discussing requirements of foundation system. When you design a foundation, what requirement should it fulfill? जाओ करना ना, safety requirement दे सकते हो, safety requirement. ना देखो हुआ चुप है पूरा अभी तुम गड़बड़ हो. The first requirement was safety requirement, and that we already have discussed. In safety requirement, can anybody explain what are the safety requirements of a foundation system? Shahid Khan? जी, कोई बता सकता है क्या है रिक्वायरमेंट?
सेटलमेंट क्राइटेरिया एंड शेयर क्राइटेरिया.
हाँ बिल्कुल, जो टेक्निकल रिक्वायरमेंट हमारे पास दो हैं, एक शेयर क्राइटेरिया that the soil beneath the foundation should not fail in shear, and settlement criteria that the settlement of the foundation should be in tolerable limits, should be in the allowed limits. और एक criteria, another criteria is with respect to safety is the structural requirement, that the foundation should be itself should be structurally strong enough to withstand the stresses in the foundation itself, like bending, shear, right, compressional stresses. That was what we discussed in the previous lecture. Now, another requirement is the depth requirement. What is depth of the requirement? Actually, this is second requirement. First requirement is the safety requirement. Now, safety होगा ना? Second is the depth requirement, spacing requirement, and it should be economical and functional. So let's discuss the second requirement, which is the depth requirement. What is the depth of the foundation? It is this. This is ground line, and this is foundation. This is base of the foundation, which is called foundation level. The distance between the ground line and the foundation line is the depth of the foundation. How much should be the depth of this foundation? What are the requirements with regard to depth of the foundation? So the first thing you have to take care of in with regard to depth is prevent movement due to soil volume changes by seasonal freezing and thawing of the ground. What does it mean? When the outside temperature is very low, is very freezing, the moisture close to in the soil, close to the ground, would freeze. And when that moisture freezes, the soil increases in volume. But when the temperature rises up, this thaws, it melts, right? The moisture thaws. When it thaws, what happens? It shrinks. So this is the, for example, the depth where this happens. This volume change happens due to freezing and thawing. So if you build your foundation base, if this base is here, right, it would be subject to movement. यार दत्ता दा foundation दा से जोड़ का है ना हम दे मान लिया वाला double arrow ऊपर और नीचे arrow वाला arrow soil movement ठीक है करना. So you have to build your foundation below this zone of volume changes, so that even if the soil volume changes, the movement is not transferred to building through this foundation. समझ आ गई आपको? If you have any question, you can ask. These are contour lines of frost depth of United States. On the south, you see there is no such requirement with regard to frost because temperatures are not freezing. But as you go to the north of the US, there are freezing temperatures and you see the depth requirement increases. Here it is 2.1 meter. If you are going to build your building somewhere here, so this gives you guidelines of how much should be the minimum depth of foundation with regard to frost depth. Second requirement is footing should be below zones of high volume changes due to moisture fluctuation. The first point was volume changes due to freezing and thawing, but the second point is due to moisture fluctuation. You see, there could be leakage of pipes, leakage from washroom, leakage from kitchens, or some rainwater seeping in to the ground, or some drain, a street drain passing nearby the house. There could be leakage, and that moisture can enter into the soil, right? So what would happen when the moisture reaches the soil? Some soil has a tendency to expand when they get moisture, and when this moisture dries up, it would shrink. Again, that movement would be transferred. This is the zone of volume changes in soil due to moisture change. Due to moisture change. So the depth of the foundation should be below this. Many soils, particularly with those of high plasticity, shrink greatly on drying and swell upon the addition of moisture. So that is the zone of volume change. The foundation should be laid below this depth. Prevent wind or water erosion. What is this? If you build, let me diagram. If you build a foundation on the ground surface, when the wind blows or when there is a water flowing water, right? So erosion would happen below the foundation base, and this would undermine the structure. So you have to give some depth so that erosion due to wind or water erosion does not occur. The fourth and last point with regard to depth of foundation is bypass unsuitable soil. If you have some unsuitable soil near to the ground, like peats, right, dump soils, so you are not going to build your foundation on such fill material. what you would do, you would start excavating the ground till you reach a very sound strata, and then you give the foundation, right? They can do diagram, unsuitable soil, there, huh? In a pile na yaar. Unsuitable soil. ठीक है बल लेकिन जो लेसी जोड़ की हाँ दिमाग पड़ा दिमाग पड़ा ठीक है अच्छा the last is prevent footing movement or distortion by plant or tree root growth. If the building is close to a tree, right, the growth of tree roots could damage the foundation. Growth these roots suck water from the soil, right? And the amount is different during different seasons. So there would be some volume changes. That's why there should be a depth, so that the changes in the volume due to roots does not affect the building. The last requirement is the spacing requirement. Spacing requirement. The foundation must be spaced appropriately in order to prevent distress in adjacent foundation. If you have already, if you already have a building, right, and you want to construct another building beside it, so what happens if you excavate the soil below the foundation of the existing building? There could be a damage. There is a video. Let me the screen share the from your side. You can see this. You see, this is an existing building. Another building is going to be constructed, but the depth of the new building is much below the existing building. You have given a greater depth. So what would happen? This would happen. This could happen depending upon the soil condition. So either what you have to do, either you have to space your new building much away, right, from the existing building, or you have to provide some supports to the excavation. So what is going here? No lateral support is provided to the existing building, nor the next building, the new building is appropriately spaced. से मतलब लेडीज से मतलब at last, the foundation that you are going to design, to construct, must be economical, and it should fulfill all the functions for which it has been designed. So these are the requirements of a good foundation system. Number one was safety requirement. Number two was depth requirement. Number three was spacing requirement. Number four was it should be economical and functional. So these are the four major and basic requirements of a foundation system. If you have any question, you can ask.
No question, sir.
Steps for designing
Hello.
a foundation.
हेलो सर.
जी
हेलो.
हेलो काफी इसमें एनिमेशन डालनी पड़ती है. अच्छा, anyway, steps for designing a foundation. If you are going to design a foundation, what steps you need to follow? First step is your office work, right? What you do, you get information about the site where the building is located. It is important. Locate the site and position of load. That is important. You should have an idea where the loads are positioned, where heavy columns are coming, where lift walls are coming, for example, where shear walls are coming. It is important. So usually during the site investigation, this is not available, but when you are designing a foundation, you must know the load position and also the loads. A rough estimate of foundation load is usually provided by the client or made in-house. Depending on the site or load system complexity, a literature survey may be started to see how others have approached similar problems. So you should have an estimate of the foundation loads before designing a foundation. It could be given by a structure engineer to you, right? And usually this is the case. Structure engineers do the analysis and he gives you the loads. In foreign countries, in developed countries, in major consultancies, what happens, there is a structure office and there is a geotechnical office. Structure office, what do? They do the structure analysis, right? And they give you the loads. But at the time of soil investigation, you do not have a very clear idea of the loads, right? Second, you go physically to site. Physically, you go to the site for any geological and other evidence, right? You go to the site and see how is the topography of the site. Is it flat? It is hilly terrain, right? Are there some trees or flowing streams? So you go and see, or if this is on a slope, is there a pre-existing slope failure? So you record all these. You also have, if you have the data of a previous boreholes in the site or around the site, that will give you a very good idea of the subsurface. So if you are running a geotechnical lab, you may have data of the sites surrounding the site where you are going to do the investigation. So if you already have some borehole around the site, you have a pretty good idea of how the field exploration should go. So at this stage, what you do, you establish a field exploration program. How many should be the borehole? What should be the depth of the boreholes, right? What type of test you should conduct in the field, and what type of test you should conduct in the laboratory. If you already have some information about the strata, right, that would be of tremendous help. Otherwise, you can build some preliminary boreholes, right, and have a good idea of how deep and how many should be the rest of the boreholes. When you conduct all these tests, boreholes, field tests, laboratory tests, for example, it's a big project and you have done, for example, 30 boreholes. You have plenty of data, right? So what to do with that data? After you conduct these tests, on your table there is a big data. You need to design your foundation based upon this data. But there is a very much scatter in the data. So based upon your experience, what you would do, you will extract soil design parameters from all this data. Extract soil design parameters from all this data. You may need some Excel sheets or some other programs that would help you organize the data and get the soil design parameters. Once you get the soil design parameters, right, based upon these soil design parameters, you have to design the foundation. Design the foundation using the soil parameter from step number 4. So while designing the foundation, you need to interact with the client, because client is the one that would pay for the foundation cost. You have to interact with the engineers, particularly structure engineer. You have to interact with the architect. You have to interact with the contractor, because contractor is the one that would actually build the foundation. Does he have enough resources, technical background to build the foundation that you have designed? A computer program for the designing is a must nowadays, because for example, you are designing a mat foundation, you have to do the structure analysis, get the moments, and design the foundation. So these are the major steps that are involved in the design of a foundation, right? For any major project. Normally what happens here, it is the structure engineer who designed the foundation and designed the superstructure and substructure both. And he has already have some bearing capacity value from the geotechnical lab. This is what the routine is. But for major structures, there has to be interaction between structural engineer and foundation engineer, right? The client, the architect, and the structural engineer. All should join hands and give economical, safe, economical, and functional foundation. If you have any question, you can ask.
No, sir, you can continue, sir.
The process is summarized through a flow chart here. Obtain site information. That is, you obtain surface information and you obtain subsurface information. About surface information, topography. You go and see what's the topography of the site, right? Some leveling data may be required here. You get the hydrology of the site, the climatic condition of the site. You need subsurface information, for which you need to drill boreholes, or you can conduct non-destructive testing, right? Which is called geophysical testing. Geophysical testing means that you do not drill any borehole, but you do other tests which you might have studied, like seismic reflection survey, seismic refraction survey, multiple analysis of surface waves, or even soil resistivity tests. These are the type of tests that are conducted on the surface of the soil, but it gives information deep into the ground. But only this geophysical testing should not be relied upon. You should need also to drill boreholes, and all this data is combined from the geophysical testing and physical testing. So you get soil and rock properties and groundwater table. Now you have all this soil information, surface and subsurface. In addition to that, you should also have structural data. What is the type of structure? Is it a bridge? It's a multi-story building? Is it a tower? Is it a concrete structure, steel structure, load-bearing walls, right? What is the type? Or is this a machine foundation or a wind turbine that you are designing for? So this data you should know. Performance criteria. How the foundation should perform under different conditions, under gravity loads, under earthquake loads, under wind load, or if you are designing a bridge foundation, right? A ship may collide with the pier. What should be the performance of the foundation at that stage, right? Or a big boulder flowing in the water coming with a velocity could hit the pier. What should be the performance of the foundation? Or a wind turbine, right, which impose a sinusoidal load on the foundation. How much? What should be the performance? And what should be the foundation loads? Axial loads. What should be the axial load? Bending moments, uplift loads, torsional loads. You should have all these loads on top of your foundation. Then when you get the soil information, you got the structure information, you go down and you have foundation alternatives. If you have a menu of foundation to pick from, you have shallow foundations. In shallow foundation, you have square footing or isolated footing, you have strip footing, you have combined footing, and combined rectangular, trapezoidal, strap footing. or mat foundation. You have deep foundations like pile foundations, ground modification for shallow foundations. This is not a type of foundation, but this is an alternative. Where there are weak soil available, you have an alternative to replace or improve that soil and provide a shallow foundation. Or you can go for a deep foundation. Whatever is economical, buildable, you go for it. Anyway, you pick an alternative, probably first from a shallow foundation. Why shallow foundation? Because it is easy to construct. It is economical, right? Then you go down and see the behavior. How much this foundation would settle? What would be the bearing capacity? Its lateral stability. Any environmental problem for constructing this foundation. Then this is the predicted behavior. You compare this with the required behavior. For example, settlement is 3 inches, but you require 1 inch. So that foundation is not going to work, right? Or the bearing factor of safety with regard to shear, you require, for example, 3, but it comes out to be 2, right? Similarly, lateral stability. And you do the cost estimate as well here. If your foundation is not working, the behavior is not good compared to the required behavior, what you would do, you go back and select another foundation type. So this cycle would go on unless you reach to the final answer. Final answer would be that the predicted behavior compares with the required behavior, right? The cost is minimal, there is no potential construction problem. Then you go down and recommend that type of foundation. And then you build drawings and prepare detailed design plans, specification. And after that, you can also monitor construction, right? Monitoring of construction, you can put some instrumentation in your foundation, and as the load, as the building is being built, you can monitor the behavior, monitor actual behavior, and see if this actual behavior is according to the predicted behavior or not. You can install piezometers in the ground to see how much is the water pressures, because when you are constructing a building, water pressure would increase, right? If this increases according to what you predicted or not. So this could be in major projects, monitoring the construction of foundation. If you have any question, you can ask.
Clear, sir.
Achha. Types of load. We talk about loads, so we will briefly talk about load. What are the different types of load? You already have an idea. There are principally 3 types: dead load, live load, and environmental loads. Dead loads are those like self-weight of a material, of a building, like what the weight of the wall, weight of the slabs, weight of the beams, weight of the columns. They are fixed in their position. They are fixed in their magnitude, right? So they are called dead loads. They are more deterministic, right? They all come upon the foundation. The foundation must be able to deal with dead loads. There is another category of load which are called live loads, like human load. The people who use the facility, there is a variation in the magnitude. At some events, the mall will be filled with people, right? but at any other time, in night time, midnight time, maybe, or early morning time, there were few people, right? And also it is not fixed in location. The people move around. So this is called live load. There are other loads that are environmental loads, like snow, wind, suction, earthquake. All these loads are environmental loads. So the foundation, the structure, and then the foundation must be able to resist all these loads. So this marks the end of chapter number 1. We would start chapter number 2, but before starting chapter number 1, if you have any question in this article or the whole chapter, you can ask. Okay. This is chapter number 2, lecture 2D. This is about bearing capacity of shallow foundation. This is very major chapter, right? Major chapter. And it will take about 4 more classes to complete. Initially, we will have some definitions, right? About different types of bearing capacities. Then we would have what are the different types of shear failures. Then we will have some bearing capacity equations, which are Tarzahi and Mehrhof. Tarzahi and Mehrhof. Then we would solve examples. So all this would take about 3 to 4 more lectures. So let's start. That is ultimate bearing capacity. Can anybody tell me what is the ultimate bearing capacity?
The load which a cell can withstand.
Sorry?
The load which a cell can withstand.
Yes, to some extent, but more specifically, can anybody answer?
Soil has no ability to more load sustain its range ultimate bearing capacity.
In the first lecture, I discussed with you a simple example, right? And what was the value of ultimate bearing capacity in that example? Can anybody recall?
10 tons per square foot.
Achha. That was 10 ton per square foot. 10 ton per square foot. The value of ultimate bearing capacity. Theoretically, it means that if you apply a pressure on the soil, if the foundation apply a pressure of 10 ton per square foot, the soil would fail in shear. The soil under the foundation would fail in shear. If you apply 9 ton per square foot, theoretically it would not fail in shear. But if you apply more than 10 or more than 10, like 15, 20 ton per square foot, it would fail in shear. So the definition would go like this. It is the least pressure which would cause shear failure of the supporting soil immediately below and adjacent to a foundation. So if you apply load on the soil, you see it would deform like this and would develop shear planes. That is called shear failure of the soil. Unit of ultimate bearing capacity is of stress units like kPa, kilonewton per meter square, or ton per square foot, or KSF, kips per square foot. Let's talk about different shear failure modes. There are 3 types of shear failure modes: general shear failure, local shear failure, and punching shear failure. General shear failure. Let's first talk about general shear failure, but prior to this, these 3 types, which one would occur, depends upon 2 parameters: compressibility of the soil and depth of footing with respect to its breadth. How much deep the foundation is. So there are 2 things. First, we will talk about compressibility, and then we will talk about the effect of depth of footing. So let's first discuss general shear failure. This is general shear failure. It would look like this. It occurs in very stiff soil. When you apply load, a wedge is formed, this wedge, that push below, and then these are the shear planes that are developed. It would rotate like this, and you have bulging of the soil on the surface. You see, this is bulging of the soil. So this is called general shear failure. If you draw the data of load and settlement, you see this is load on the x-axis, on the y-axis you have settlement of the foundation. As you increase the load, settlement would increase, and at certain point it reaches the maximum load, and then there is a break. Once the shear planes are developed, the load is decreased. This is called ultimate load, and you can find the ultimate load from the graph very readily, very easily. So this type of failure occurs in, it is characterized by well-defined failure pattern. This is failure pattern, you see, consisting of a wedge, this is wedge, and slip surfaces and bulging of soil surface adjacent to the footing. Yeah, this is bulging. Sudden collapse occurs, accompanied by tilting of the footing. In general shear failure, when the failure occurs, you would see there is a tilting. The foundation would tilt on one side, it would rotate on one side. Occurs in dense or very stiff soil. Failure load is well defined. You can read failure load from the curve very easy. This is called general shear failure. If you have any question, you can ask.
सर ये डायग्राम जरा डिस्कस करें, इसमें समझ नहीं आ रहा है.
अच्छा, देखें इसमें if you apply load on the foundation and you place some gauges, right? Like in plate load test. In plate load test, what you do? This is one of the way to find out bearing capacity of the soil. You go to the site and place some steel plates on the ground, and on that steel plate you place a jack and push it down into the ground. Also, you place some displacement gauges on the plate. So what you measure load and corresponding settlement. When you plot load and that settlement, and if it is a stiff soil and general shear of failure type, you can have such kind of graph. The peak corresponds to the ultimate load. Once after this, shear planes are developed and the capacity is reduced. You see, here the capacity is reduced. You see, after failure, the capacity is this. Before failure, the capacity is this. This is ultimate load.
ओके सर।
सर जी, स्टीफ साइल में क्यों अकर होता है?
स्टीफ साइल में क्यों अकर होता है? Because if it is soft soil would settle before developing such shear planes. Like आपके पास कोई rigid material like a chalk, right? This failure is much like a stiff, rigid material. Like if you take a chalk and you apply a load, you would see no displacement, and all of a sudden there will be a breakage, right? But if you take a soft material, right, you would not see these shear planes, but it would bend like this. It would settle. So that's why it's characterized in very stiff soil where shear planes are developed. If it were not stiff soil, it's soft soil like the ones that are coming up, they would partially develop shear planes and they would settle more.
Excuse me, sir.
Ji.
Sir, how the soil will move on these planes?
Ji. Clear. This wedge, first this wedge is formed, right? And when it pushes down, this is called radial passive zone that you would read in Karzai bearing capacity equation, because Karzai bearing capacity equation is based upon general shear failure. This wedge would rotate, right? And this would also rotate and would move up. So this is the type of movement that would occur, but it's very small movement, because it is very rigid soil. Small movement would create a slip planes like a chalk. When you apply a load, you don't see any movement, and all of a sudden what happens, shear planes are developed. Okay. Now, local shear failure. Local shear failure would occur in compressible soils. In compressible soils, like this. The shear planes are developed like this, but they do not go up to the ground, and there is slight bulging. But there is greater displacement compared to the general shear failure, like this. The general shear failure curve would come somewhere here, like this, but local shear failure would be down here. There are greater displacement. This is general shear failure. Look, you see, for the same load, there is greater displacement in the local shear failure. Failure pattern consists of wedge and slip surface, but is well defined only under the footing. Only under the footing they are defined. Slight bulging of soil surface occurs. Tilting of footing is not expected. Large settlement occurs. Ultimate load is not well defined. like in the case of general shear failure, you pick the load here, it is not very well defined. Occurs in soil of high compressibility.
सर ये लोकल जनरल शेयर फेलियर से क्यों तब्दील है?
जी
सर ये लोकल शेयर फेलियर का कर्व जो है सर ये जनरल से क्यों इस तरह तब्दील है? क्या वजह है इसके पीछे?
वो तो देखें मटेरियल डिफरेंट हो गया ना. The material is now different. That was very stiff, right? And and this one is a bit plastic, right? In plastic, you would not see actually where is the actual failure load. Or your stiff material है, there you would see. ठीक है ना? प्लास्टिक मटेरियल है, उसमें सेटलमेंट भी ज्यादा होती है, उसमें अल्टीमेट लोड का भी क्लियर पता नहीं लगता. अब ये इसमें तो फिर भी आपको कुछ अंदाजा हो जाता है, बट जो पंचिंग शेयर फेलियर है इसके बाद जो आता है वो तो बहुत ज्यादा सॉफ्ट सॉइल में आता है, उसमें आपको कुछ अंदाजा नहीं होता. देयर एंड दैट settlement actually controls on those type of soils. The third one is the punching shear failure. This is punching. This occurs in very soft soil, right? As you apply load, the like plastic movement would occur, and the foundation would continue to settle with large displacements. And curve would be like this. You see, this is general, this is local, and this is your punching shear. Here, failure pattern is not well defined. You see, you cannot pick the peak. Sorry, failure pattern here. You see, was only of which is not very well defined. The slip planes cannot move up because they are not very stiff soils. No bulging of ground surface, no tilting of foundation. Failure takes place immediately below footing and surrounding soil remains relatively unaffected. Failure occurs just below this. It moves down like punch. It is punching into the ground. Occurs in soil of very high compressibility. The last sentence, I'm not reading, I would explain it to you, but till now, if you have any question, you can ask. So this is one of the aspect of shear failure types, which was based upon compressibility of soil. Another aspect which I told you is about depth of the footing. So the last sentence says about punching shear failure, it occurs not only in very high compressible soil, but it could also occur in stiff soils, provided that the depth of foundation is very high. If depth of foundation is very high, like here,
different types of water within the soil. Capacity, all these have been discussed in this class. We have reached up to this slide.
Okay, thank you. So you see this graph. This is called relative density of sand. So as you move this in this direction, the soil becomes very stiff. And this is depth of foundation relative to breadth of foundation. So this is breadth of foundation and this is depth of foundation. This is depth of foundation and this is the diameter or breadth of foundation. So as you move towards the right, the soil becomes very stiff. And as you move down here, the depth of foundation increases. So let's discuss this. This is soil of very stiff soil. So what type of failure is occurring? General shear failure. General shear failure. But as you go down and the depth of foundation increases, you move into local shear failure, and still when you move further down, it becomes punching shear failure. So the type of failures not only depend upon the compressibility of soil, but it also depends upon how much deep the foundation is relative to the foundation, relative to the breadth or diameter of the footing. T is greater than V milligram. Achha, if you have any question, you can ask. अच्छा
सर
जी जी
सर ये रिलेटिव डेप्थ मतलब ये इफेक्ट क्यों किस तरह इफेक्ट काज करता है लाइक डेप्थ टू बेस रेशियो के साथ कैसे ताल्लुक
अच्छा देखें फॉर एग्जांपल this is a pile foundation which is very deep and it is a stiff soil. Assume this is very stiff soil. So according to our understanding, there should be general shear failure because it is stiff soil. But according to this graph, the depth is more, so it could be a local or a punching shear failure, right? Why? For example, if you see here on the base of the foundation, that is the base of the foundation, there is a huge soil pressure on this level, right? So when a wedge is formed and the cracks, shear planes try to propagate up, this soil pressure, which is very huge, would try to contain these cracks, and making the failure from general to local shear failure, for example.
Yes,
so
sir, yes, sir. Now I get it.
Very high pressure.
Yes, sir, thank you.
So as we discuss different types of foundation pressure, different type of shear failures, and failures occur due to pressure, due to foundation pressure, right? So let's discuss what type of foundation pressures are, right? Number one is gross pressure. Number two is net pressure. So let's define both gross pressure and net pressure. First, let's discuss gross pressure. So at this level, what do you think the pressure would be? From which sources? What are the sources of pressure at this level? Can anybody tell me?
स्ट्रक्चर लोड की वजह से
स्ट्रक्चर लोड की वजह से। तो स्ट्रक्चर लोड आप एज्यूम करें कि यहाँ पे आ रहा है, यहाँ पे इसकी, मगर लेवल आपका यहाँ पे है, और कुछ लोड भी आएंगे ना।
सोइल लोड,
कौन सा
सोइल लोड भी है सर,
ये वाला
जिसके ऊपर है ना,
ये वाला जो इसके ऊपर है, इसको कहते हैं बैकफिल सॉइल, इसको कहते हैं बैकफिल, क्योंकि फर्स्ट यू डू द एक्सकेवेशन like this, then you build the foundation, and then you pour in the excavated material and compact it in layers, and that is backfill. So the soil, the backfill. And another, any other? The weight of foundation itself, that is also coming upon the soil. So it is structure load, it is foundation load, all this, and it is backfill soil. This is backfill soil. Backfill soil. By 2 means a symmetrical soil. So if I want you to, these are loads. If I want you to find the pressure at this level, what you would do?
Sum them up.
And
Divide by area.
G.
सर दोबारा repeat करिए question.
G.
Sir, and divide by the area.
Which area?
Sir, the lower foundation area.
Achha. So for square footing, what it would be equal to? Assuming that this is the depth of the foundation and this is the breadth of the foundation. This is B and this is D, depth, and this is B, width of the foundation. So what would be the foundation area for a square footing?
B square.
B square. Okay, good. This Q gross would be equal to WSS, WF, WBS divided by A, which is area of the footing. And Q is equal to gamma D. The pressure outside the foundation plane is the self weight of the soil. This is unit weight of the soil, and this is D. Q is equal to gamma D.
सर ये एरिया सर दोबारा समझा दे काइंडली.
ये एरिया जो है ना, ये वाला एरिया है, देखिए, दिस इज बी. B into B, this is the area of contact of foundation with the soil. ठीक है ना? B into B जो है for square footing, it is B into B. What is this A? It is the area of contact of the foundation with the soil. ठीक है, which is distributing this load. Like in the example, first example, the area was 5 by 5 feet. So 5 by 5 feet was a square footing, and the area was 25 feet square.
Clear, sir. Thank you.
This is Q gross. This pressure that is transferred to the soil from the foundation is Q gross. Now you tell me, before the construction of the foundation, what was the pressure at this level?
The pressure outside of this. Sorry, Q is equal to gamma D.
Q is equal
Self
to
weight of soil.
Q is equal
Gamma
to
D, sir.
gamma D. So
Gamma D के
prior to the construction of foundation, the pressure on the soil was gamma D or Q, and now the pressure on the soil is how much? How much?
Q
gross.
Q gross. So how much is the increase in pressure that the soil would experience? How much increase in pressure the soil would experience under the foundation?
Q gross minus Q.
Q gross minus Q. It is as if there were 2 bags on your back, and I remove these 2 bags and put 10 bags, right? So how much is the increase in the load? it is at 8 bags, right? So that increase in load is called net pressure. Prior to the construction was Q is equal to gamma D. After construction, it's Q gross. Net pressure is Q gross minus gamma D. This is called net pressure. You can put in the values of Q gross here. Q gross is this from the previous slide, and minus gamma D. In this equation, if you assume that weight of the foundation and weight of the backfill soil is same, weight of the foundation, you assume it, right, that weight of the foundation, which is concrete, is roughly equal to the weight of the soil. So weight of foundation plus weight of the soil divided by area would be roughly equal to gamma into D, unit weight of soil into depth of foundation. Do you agree with this?
Yes, sir.
Yes.
Okay. If you replace in this equation with gamma D, plus gamma D cancel with minus gamma D, and Q net would be roughly equal to weight of the structure or weight load from the columns or weight of the structure divided by area of the foundation. Q net would be roughly equal to, but very closely equal to, this. Do you have any question?
No, sir.
Take a 5 minutes break and then we would continue.
Yes,
During
sir.
this time, you can think over what we have already studied, and if you have questions, you can ask. अच्छा अच्छा, Bismillahirrahmanirrahim. So that was the net pressure intensity. It is increase in pressure at foundation level being the total weight less the weight of the soil permanently removed, that we explained. अच्छा जी, safe bearing capacity. Can anybody tell me what is safe bearing capacity? जी, बता मुझे। Safe bearing capacity. If you remember from the example in lecture number 1, a simple example that we discussed, we use safe bearing capacity. The value, do you remember the value of that safe bearing capacity that we used in that example?
4.5.
No.
6.1.
It was 2.5 ton per square foot. So at that time I explained to you what is safe bearing capacity. Can anybody explain it?
Sir, the bearing capacity after application of factor of safety, sir.
Factor of safety against shear failure. Factor of safety against shear failure. So the question is Q ultimate divided by factor of safety. In that example, we assume factor of safety equals to 4 and Q ultimate was 10. So 10 divided by 4, it was 2.5 ton per square foot, right? But generally, the factor of safety varies from 2.5 to 3. But you can pick a higher value of factor of safety, depends upon your confidence on the soil properties, on the test that you have conducted, right? If you are confident about the quality of the test you have conducted, you can use a lower value. But if you are not confident about the soil properties, you have used some crude methods, so you can take a higher value of factor of safety. Similarly, if some other things could happen like change of conditions, loads, so to take into account all these uncertainties, they are lumped into factor of safety. So though 10 ton per square foot is the value which if applied would cause shear failure, but you want to be much away, much below that value to be safe, because shear failure is very catastrophic. It is very dangerous. So the thing which is very dangerous, you want to be as much away from the dangerous thing. So you use factor of safety, right? The more the factor of safety, the more you are away from that dangerous situation, right? Q safe in terms of could be represented in terms of net pressure. Like Q safe in terms of net pressure is equal to Q ultimate in terms of net pressure divided by factor of safety. And Q ultimate minus gamma D, right, is divided by factor of safety is Q safe in terms of net. From where you will get this Q ultimate, that would be from different methods. The one that we would discuss would be Tarzahi bearing capacity equation and Meyerhof bearing capacity equation. From there you will get Q ultimate. minus gamma D would make it net in terms of net divided by factor of safety. So you got Q safe in terms of net. So if you use this equation or that equation, so what is the difference? Where is the difference lies? What does it actually mean? If you are using this equation, your applied pressure should be less than or equal to Q safe. This is the limit. Your applied pressure should be, this is the capacity. Q safe is the capacity of the soil, right? The applied pressure should be less than Q safe. Let me write it here. Should be less than or equal to if you are using net pressure, then applied net pressure will be less than or equal to Q safe in terms of net. If you have any question, you can ask. जी समझ आ गई है?
Yes, sir.
Allowable bearing capacity QA. Can anybody tell me what is allowable bearing capacity, keeping in view the example that we studied? जी
अरे जिसकी वैल्यू सेफ बेरिंग कैपेसिटी से कम है।
जी जी आवाज मेरा
जो अल्टीमेट बेरिंग कैपेसिटी से कम हो।
If you remember in the example,
अल्टीमेट bearing capacity
I
divided
gave
by
you two
factor of
values.
safety, sir.
One is safe bearing capacity, which was 2.5 ton per square foot. Another value was related to the settlement of foundation. 1 inch settlement of foundation, the pressure was 1.8 ton per square foot, if you remember. So the minimum of these two pressure is actually allowable bearing capacity. Allowable bearing capacity is the one that takes into account both the shear failure. Q safe, this Q safe only takes into account the shear failure. Shear failure, you see, to avoid shear failure. But Q allowable takes into account both settlement and shear failure. So allowable bearing capacity is the maximum pressure which may be applied to the soil such that the two fundamental requirements are satisfied. What are those two requirements? Limiting the settlement to a tolerable amount, shear failure of the supporting soil is prevented. These two are the requirements. So if you remember, the value of B in the example was 2.5 ton per square foot and the A was 1.8 ton per square foot. So we have two criterion. Shear criterion Q safe in terms of net is equal to Q ultimate to net over factor of safety. This is one criteria which takes into account a shear failure, guard against shear failure of the soil. The next criteria is the settlement criterion Q net that limits the settlement to a tolerable amount. So whichever is minimum of these two will give you allowable bearing capacity. In the simple example which was not detailed, this value was 2.5 ton per square foot and this value was 1.8 ton per square foot. So can anybody tell me what would be the allowable bearing capacity that you need?
Less than 1.8.
1.8 or less than 1.8, right? So what does actually mean if allowable bearing capacity is 1.8 ton per square foot? So what you are going to do with this value?
सर जी इससे ज्यादा प्रेशर अप्लाई नहीं करेंगे.
Yes.
1.8.
Good. इसमें यहाँ पे एक Q net क्या देखें, वही आप कॉपी कर लेते हैं. समझ आ गई? Any question?
सर ये क्यू सेफ नेट हमेशा मिनिमम वैल्यू नहीं होगी क्योंकि हम अल्टीमेट बेयरिंग कैपेसिटी उससे ज्यादा एक्सेस में जा नहीं रहे तो सेटलमेंट होगी ही नहीं.
जी दोबारा पूछें.
सर जो शेयर क्राइटेरियम और सेटलमेंट क्राइटेरियम में से शेयर क्राइटेरियम हमेशा मिनिमम वैल्यू नहीं होगी क्योंकि हम अगर अल्टीमेट बेयरिंग कैपेसिटी से एक्सीड नहीं हो रहे तो सेटलमेंट कॉज ही नहीं होगी.
नहीं इस तरह नहीं है. यूजुअली जो क्राइटेरियम गवर्न करती है ना वो सेटलमेंट वाली करती है यूजुअली, ठीक है ना. और ये दोनों अलग क्राइटेरिया है. सेटलमेंट अलग चीज है और शेयर अलग चीज है. जिस तरह बल्कि आप जो एनी डिजाइन दैट यू डू इन सिविल इंजीनियरिंग, लाइक यू डिजाइन अ बीम और अ कॉलम, राइट, always two things must be go parallel. One is called strength criteria, the other is called serviceability criteria. If you are going to design a beam, right, so the beam must not fail in shear or flexure. This is called strength requirement. ठीक है. Another requirement is the serviceability requirement or settlement requirement. That the okay, you have designed a beam which is strong enough that it would not break, but it could deflect. It could settle in the mid, right? So there is another criteria which is related to deflection of the building, right, of the beam. So यहाँ पे भी ये दो criteria parallel में चलती हैं. Number one is related to the strength criteria. The second is the serviceability criteria. Both should be followed. In some cases, there would not be any shear failure, but there would be settlement which is not acceptable, right? And the settlement varies, criteria varies for different structure. For example, for a machine foundation, you would not allow, you would allow only small amount of settlement. You cannot tolerate more settlement, because if there are more settlement, there could be wear and tear in the machines and it could dysfunction. In some cases, you can allow more settlement. So that both, you have to evaluate both, right? And see what is minimum. And in the example that we studied, it was 2.5 ton per square foot and it was 1.8 ton per square foot. So the design of the foundation is governed in that example by the settlement criteria.
Okay, sir. Thank you.
Okay, that marks the end of our lecture. Now, attendance value. If you have any question in this lecture or previous lecture, you can ask.
सर ये डी बाई बी रेशियो समझे ये ग्राफ
ये ग्राफ. अच्छा जी, देखें ये types of different types of settlement. We discussed that for very stiff soil. Look, relative density of soil, and this corner, the density of the soil is very high, right? So if you go down, this is depth of foundation, you experience general shear failure. But as the depth increases, the same stiff soil will give you local shear failure. Here you will experience local shear failure. But if you further give more depth to the foundation, it would go into punching shear. This is punching shear zone. So even for the same stiff soil and different foundation with different depths, you will experience, the soil will experience different types of shear failure. And I explained for an example. For example, this is very stiff soil. For example, the stiffness is 0.8, density is 0.8, which is very high density, and the depth is very large. So if you come here to this depth, because depth here is more, you are in local shear failure. And the reason I explained to you was because at this level the soil is so huge on the shear planes that it wants to contain these cracks and not let it propagate up to the ground.
Yes, sir.
Any other question?